Good day everyone, I am Brenda Macy Ramos and I am going to discuss the following series and I am going to give one example each.
So we have here geometric series. A geometric series is any series that can be written in the form summation of AR raised to n minus 1, n equals 1 to infinity. Or with an index shift, the geometric series will often be written as summation of AR raised to n is equal to 0 to infinity. So we have here an example. Summation of negative 2 raised to 3n over 4 raised to n minus 1 from n is equals to 0 to infinity is equals to, so summation of negative 2 raised to 3 raised to n over 4n times 4 raised to negative 1, n is equals to 0 to infinity. So we are going to put the 4 in front. So summation of 4 times negative 2 raised to 3 is negative 8 raised to n. So ang matitira is over 4 over n. Next, we have summation of 4 times negative 8 over 4 raised to n is equals to 0 to infinity. So our a here is 4 and our r is negative 8 over 4. So if our r is greater than 1, then it is divergent. Since our r is negative 8 over 4, that is equals to 2. So our given is divergent. So we have here the alternating series. An alternating series is any series summation of a's of n for which the series terms can be written in one of the following two terms. A's of n is equals to negative n raised to n times b of n, where b of n is greater than or less than 0. Next is a's of n is equals to negative 1 raised to n plus 1 times b of n, where b of n is greater than or equal to 0. So an alternating series is an infinite series in which the terms alternate signs, meaning some terms are positive and others are negative. So we have here an example. S is equals to 1 minus 1 half plus 1 third minus 1 fourth plus 1 fifth and so on and so forth. So the partial sum of the first 4 terms. So we have S4. So 1 minus 1 half plus 1 third minus 1 fourth. So let's separate the 4. So we have here the first one, 1 minus 1 half plus 1 third minus 1 fourth. So 1 minus 1 half is equals to 1 half plus 1 third minus 1 fourth is equals to 1 over 12. So 1 half plus 1 over 12 is equals to 7 over 12 or 0.5833. So our R4 is negative 1 raised to 5 times 1 fifth is equals to 1 fifth. Therefore, the sum of the alternating series S is approximately 7 over 12 with an error less than 1 fifth. Next, we have power series. A series of the form summation of c of n, x raised to n is equals to 0 to infinity is a power series centered at x equals to 0. A series of the form summation of c of n times x minus a raised to n is equals to 0 to infinity is a power series centered at x is equals to a. So we have here an example. H of x is equals to 2x squared over 1 plus x raised to 3. So we have to put 2x squared in front and to have 1 over 1 plus x raised to 3. So 2x squared, the summation of negative 1 raised to n times x raised to 3 over n is equals to 0 to infinity. So our x is less than 1. So h of x is equals to summation of 2 times negative 1 raised to n x raised to 3n plus 2 is equals to 0 to infinity. Next, we have the interval of convergence. So the set of real numbers x for which a power series converges. So we have here an example. Summation of x minus 6 raised to n over n raised to n where n is equals to 1 to infinity. So limit n is to infinity, the absolute value of x minus 6 raised to n over n raised to n. So is raised to 1 over n. So the limit absolute value of x minus 6 over n. So let us put x minus 6 in front and limit n to infinity 1 over n equals to 0. So our limit 0 is less than 1, which is it is converged. Next, we have radius of convergence. If there exists a real number r is greater than 0 such that the power series centered at x is equals to a converges for absolute value of x minus a is less than r and diverges for absolute value of x minus a is greater than r, then r is the radius of convergence. If the power series only converges at x is equals to a, the radius of convergence is r equals to 0. If the power series converges for all real numbers x, the radius convergence is r to infinity. So we have here an example. Summation of n factorial times 2x plus 1 raised to n is equals to 0 to infinity. So let's get the limit. Limit n is to infinity, the absolute value of n plus 1 factorial times 2x plus 1 raised to n plus 1 over n factorial times 2x plus 1 raised to n. So limit of n is to infinity, n plus 1 times n factorial times 2x plus 1 over n factorial. The absolute value of 2x plus 1, limit n to infinity times n plus 1. So we have here the limit infinity is greater than 1. So x is not equal to 1/2. So radius of convergence is equals to 0.
Next, we have the Maclaurin series. So, a Maclaurin series is a special case of the Taylor series that uses 0 as our single point. So, we have here an example. So, we have the step 1 for our example is f of x is equals to ln 1 plus x. So, our first derivative is 1 over 1 plus x. So, our second derivative is negative 1 over 1 plus x squared. So, our third derivative is 2 over 1 plus x raised to 3. And our fourth derivative is negative 6 over 1 plus x raised to 4. So, analyzing the derivatives, we can identify the following pattern for n is greater than 0. So, f raised to n times x is equals to negative 1 raised to n minus 1. N minus 1 factorial over 1 plus x raised to n. So, each consecutive derivative changes sign in relation to the previous derivative. Hence, the factor negative 1 raised to n minus 1. So, the numerators form a sequence of rule n minus 1 factorial. So, the denominators are just powers of 1 plus x. So, next we have the step 2. So, evaluate each derivative at x is equals to 0. So, let our x as 0. So, the first one, f times 0 is equals to 0. So, the first derivative is 1. The second one is negative 1. The third is 2. And the fourth is negative 6. So, our f of n times 0 is equals to negative 1 raised to n minus 1, n minus 1 factorial. So, next, step 3. So, applying these results to the Maclaurin series formula. So, f of x is equals to 0 plus 1 times x plus negative 1 over 2 factorial times x squared plus 2 factorial over 3 factorial times x cubed plus negative 3 factorial over 4 factorial times 4x and so on and so forth. So, our m of x is equals to x minus x squared over 2 plus x cubed over 3 minus x to the 4th power over 4 plus and so on and so forth. So, our final answer here, in sigma notation, we have summation of negative 1 raised to n minus 1 times x over n raised to x raised to n over n, which n is equals to 1 to infinity. Lastly, we have the Taylor series or Taylor polynomial. It's a representation of a function as an infinite sum of terms calculated from the values of its derivatives at a single point. So we have here an example. So to find the Taylor series for a function, we will need to determine a general formula for f raised to n times a. So this is one of the few functions where this is easy to do right from the start. So to get the formula of n raised to n times 0, all we need to do is to recognize that f of n, f raised to n times x is equals to e of x. So let's first have n is equals to 0, 1, 2, 3. So our f of n here times 0 equals to e raised to 0 is equals to 1. So therefore, the Taylor series for f of x is equals to e raised to x about x is equals to 0 is e of x equals to a summation of 1 over n factorial times x of n is equals to 0 to infinity. So our final answer is summation of x raised to n over n factorial. So n is equals to 0 to infinity. Thank you for watching.